All right, so we're going to keep going here with 2-8 applications here. So still using some right triangle trigonometry with these. So this one here, you've got a hot air balloon. So I'm just going to kind of draw a picture of a hot air balloon, something up here, whatever. And then it's floating above a straight road. So there's a road down here going. All right. So we got some angle of depressions going on here. So I'm going to draw this, and then I've got some angles of depression coming down here. We'll do one there, and then we'll do one that says 15 degrees. So the one out here is um, the one that has a smaller angle, and if I draw one in here farther, this one is more steep. So the one on the outside, you can tell as you're going in from, if you watch the line there, you can visually see that 15 degrees is a smaller angle than that 20-degree angle. It says we got 2 consecutive mileposts. So from this post to this post here, this is 1 mile in here. All right. And then how high is the air balloon here? So that's this. So we also don't know something else. We don't know this distance in here. So if you look at the inside triangle, so I'm looking at this triangle right here, we can set up a ratio for that. And we know that this here from over here is my opposite. We know this here is my adjacent. So we know from SOHCAHTOA that we're dealing with tangent because that's opposite and adjacent. So I'm going to set up a tangent ratio. I'm going to say tangent of 20 is equal to my opposite over my adjacent. I'm also going to do the same thing with the tangent of 15. So I'm going to come here on the outside. Maybe I'll use blue. So I've got another triangle right there in the blue. So if I set that one up, it's going to go the tangent of 15. And 15 here, this is still my opposite over here, but my adjacent happens to be this distance right in here, which is y plus 1. So my adjacent is x over y plus 1. So what I'm going to do in both of these cases here, I'm going to solve for x. Because if the x's are equal to each other, which they are, the same, this side length is the same for both of the triangles there, then I can take the other portions, set them equal to each other, and solve for y. So that's my goal there. So if I multiply here, I'm going to solve for x. So I get x equals y times the tangent of 20. Over here, solving for x, same thing. I get x equals y plus 1 times the tangent of 15. I can tell that both the x's are exactly the same, so I can set this portion and this portion equal to each other. I'm going to do that. And I'm going to solve for y. Now, if it makes more sense to you, you could actually find a value for the tangent of 15 and the tangent of 20. But when I do something like that, I usually take it out quite a few decimal places just to keep it exact as possible. So tangent of 20 there. Tangent of 20 there, I'm getting 0.3640. I'm going to go up 4 places. 3640y. Over here, the tangent of 15 ends up being 0.2679, and I still have this y plus 1. So I'm going to have to distribute this through, and when I do that, I get 0.3640y equals 0.2679y plus 0.2679. So distributing that through. I have to get my y's on the same side, so I'm going to have to subtract off. 79y. So I've got to take 0.3640 minus 0.2679. And I'm getting 0.0961 equals 0.2679. I forgot my y in there. So now I'm still solving for y, so I've got to go ahead, divide by 0.0961. 0.0961. So 0.2679 divided by 0.0961. And I end up getting y ends up being about 2.7877 for now. All right, but it says x over here. We need to find x. The question is, how high is the balloon? We want to know this. We want to know x. So let's plug in y. So x equals 2.7877 times the tangent of 20. So 2.7877 tangent 20. And I end up getting x ends up being about 1.01 miles. So how high is this balloon? .01 miles. Yes, you're going to have to do one of those on your test, so make sure you go through that. Make sure you practice them, try one out, maybe go home, erase this whole thing and do it yourself, or, you know, do it on a separate sheet of paper and watch your answers through. Example 7 here, the measure of angle A here is 20 degrees. AB here is 32 centimeters, so notice how I'm labeling everything. Measure of E over here is 20 degrees. BC there in here, that's this little portion right there, that's 5. And then we're supposed to find all the way from A to E. So let's go ahead and figure this out here. So I am going to have to find AD in here, so I can easily find AD because I have my hypotenuse for this triangle over here, and I could find out what this adjacent side is, so I could use cosine. So I could say cosine of 20 is equal to my adjacent, which I don't know, so I'm just going to call this maybe A over my hypotenuse, which is 32. So I'm going to, well, maybe I should call that AD so I don't get it mixed up. AD. So multiplying across here, so AD ends up being 32 times the cosine of 20. So 32 cosine 20 gives me about 30.1. All right, oh, 30.1. All right, so now if I can find DE, the problem is with this angle, this triangle over here, I don't have any sides. So I might also have to do something with this triangle ADB over here, this bigger triangle over there, to figure out what the length there of CD is. So I've already figured out what AD is, so now I need to find out what BD is over there. So I could do a couple of things. I could use the Pythagorean theorem. I could also go ahead and maybe better there, this is my opposite, BD is opposite from that angle A over there. So I could go back and use my trig stuff again. I could say the sine of 20 is equal to my opposite, which is BD, divided by my hypotenuse there, which is 32. So BD ends up being 32 sine 20. So 32 sine 20. And I end up getting BD is about 10.9. But that's BD. We have BC there is 5. So to find CD, I can take BD and subtract BC. So BD there is 10.9. BC there is 5. So I end up getting 5.9 there for CD. All right, so now I've got the triangle over here that I need to find DE here with. So this here is my opposite. This here is my adjacent. So let's go ahead and use a tangent ratio. So the tangent of 10 is equal to the opposite over my adjacent, which I don't have. And I'm going to call this DE. So using my cross products, I have 5.9 and divide by what's across from DE. So DE there ends up being 5.9 divided by the tangent of 10. And I end up getting about 33.5. So AE is equal to 30.1 plus 33.5. So 30.1 plus 33.5 ends up giving us 63.6. Ends up being the value that we're looking for. It says round to 1 decimal place, and we've rounded that to 1 decimal place. All right, so I can apply right triangle trigonometry to application problems, and I can find missing sides and angles of isosceles triangles. Those were our two goals. So your assignment is to do the 2-8 worksheet for Tuesday, and then we'll review on Tuesday, and then we'll have a test on Wednesday.